Hello guys, today we will be doing implementation of stack using linked list. Okay, so before that let's discuss basic intro. Let's have a basic intro about stack. So stack is a linear data structure which stores data in a particular order and so that few operations can be performed efficiently. So the order is LIFO order. Okay, so LIFO order is nothing but last in first out. So whichever element that is pushed into the stack at the last is popped first, or first in last out, or first in last out states that whichever element is popped at the first will be popped out last, and that's how we perform the operations over the data. So you can have seen a lot of real life examples of stack, like in a canteen you may have seen a stack of plates kept over one another, and whenever you go there you pick up this plate which is on the top of the stack, and whenever the employee comes with a few more set of plates they keep again on the top of the stack, and that's how uh, uh, again the stack grows and again the top element changes. Then we keep on adding keep on popping out from the top as the people go to the canteen and eat. They will pick up the top plates, and at the end the last plate will be taken. Okay, so the last plate remains there for the bottommost position. The bottommost plate remains there for the longest period of time in the inner stack. Okay, this is what basically a stack is. So now let's check out what are the operations that we can do in a stack. So basically there are three operations: push, pop and peek. Push is nothing but adding element to the stack, that is push. Whenever the employee comes and put a set of plate on the stack of plates, collection of few plates he brings and he put over the stack of plates, then that is pushing the stack. We push one element at a time. Okay, and using this push function, and pops one element at a time from the top of the stack, and peek simply checks out the element which is at the top of the stack. It doesn't removes anything, it just checks. Okay, have a check what is there. And we need to keep one more condition in the pop, that if the stack is empty then nothing, then none will be returned. Okay, null will be returned by pop, stating that the stack is empty. Okay, and there is one more function, is empty. So this returns whether a stack is empty or not. Okay, so if it is empty returns true, that means stack is empty. If it returns false, that means stack is not empty. There are few elements in the stack. So all these four operations takes big of one time, that is constant time, as we don't need to run any loop through it. Okay. Now I'll be using Python to implement the linked list for stack. So in Python we can implement stack using list, collection, dequeues, queues and LIFO. For list I have already made a video, and in this video we'll be using linked list to implement stack. Okay, let's check out the code. This is how the code look like. We first define the node class. This node class is to store the data and the next pointer. Okay, and now we are creating a class. We will initialize head as none and length as 0, and now we'll push elements in the stack. So whenever we push a new element, if whenever we push a new element, uh, new node new node will instantiate a node with having value as data. Okay, and then new node dot next will make as head, and then we will make head as new node, and we'll simply increment the length by 1. That's all we need to do. So push doesn't returns anything, it just simply adds the data on the top of the stack, and the head value change points to the top of the stack. Okay, and now let's see what is the pop function. So pop function it returns that data which is at the top of the stack. So first we'll check whether length is 0 or not. If length is 0, that means it is the underflow condition. So underflow condition, it will return none as the stack is empty. Now if it's not the case, it means some elements are there, then we'll make a variable item as which will be equal to head, and then we'll make point head to the next value when the pointer is pointing to the next node. We'll move head one step forward, then we'll decrement the length by 1. Okay, and then we'll make item dot next as none since it is being deleted. Okay, and then we'll return head dot data. Okay, sorry, this will be item dot data. Yeah, this will be item dot data. I will make item dot next as none, and then we'll return item dot data. So item is the value which was at the top of the stack, and it gets returned. Okay, the data value of it, and we make the pointer as none so that after garbage collection it will be deleted. Okay, now let's see peek. So what peek function does, it checks what is at the top of the stack. So when we will run peek, first we'll check whether the length is 0 or not. If length is 0, this is underflow condition, that means stack is empty, so it will return none. Otherwise it will simply return the value of head dot data. Okay, whatever head dot data is having, it will return. Now we'll check. Now let's see what the isEmpty function does. IsEmpty function just returns whatever length is equal to 0 or not. If it is 0, then it will return true. If it is not 0, then it will return not 0, then it will return false. We can also make it less than equal to 0. Okay, this one is more correct. Anyways, it will not go beyond below 0, because wherever it reaches 0, it doesn't reaches this statement. Okay, -1. So this statement is more correct. If length is less than or equal to 0, so that states that the stack is in empty condition. The stack is empty. Now let's check size function. The size function returns the length of the stack. That's it, guys. Huh? So these are the operations which we are doing. First we are instantiating the stack, then we are checking whether it is empty or not, then we are checking the size of it, then we are peeking it, then again we are checking whether it's empty or not. And let's do one more statement. Print is stack value, stack top value. Stack top value is equal to stk dot pop. Yeah, it returns the top value of the stack. So let's add this code over in our IDE also, and let's now see the code examples. Let's reach Python. So this is how the code is. This is how the code is. Whatever I showed you, that's only we are doing. Whatever I showed you, that's only we are doing. And just see the code one more time. These are the operations what we are doing, and pop was returning. Here we will have to make item dot data. Okay, yeah, that's it. Now let's run the code. What is the problem? Pop self.item.data. Sorry, it won't be self, it will be item.data. Yeah. stack, stack top value. Yeah. Now let's run this code. Yeah. This is what we got. Here the stack empty. We got true initially. Initially we initialize the stack, and we have just initialized the stack, so it will be empty. So it returned true. Now we are adding data first in it, then we are adding data new in it. Then now we are checking the size of stack. Size of stack gave us true. Now we are adding bens in it, and we are picking the top of the stack. So we got bens. Again we are checking the size. We got 3. Now we are making the stack empty, checking whether the stack is empty or not. It returned false. So there are elements in the stack, and top value of the stack is bens. Yeah. At the last, we popped out the last. Again, if we do pop operation, then this time it will print data new. Let us do it multiple times. Yeah. See, now it is printing none. So it printed it. Pens was popped first, then data new came out first. See, the order in which we inserted, first was inserted initially, so it came out at the last. Okay, data first was popped out at the last. Now if you check the size of stack, it will be size of stack is 0. Yeah. So you can see it is working fine. So this is how you can implement stack, guys, using linked list in Python. In any language you can do. Okay, the code will be similar. You just need to follow these steps, and whether it's C, Java, or C++, whatever programming language you follow, the basic thing, you just need to change how the definitions for that language are, but the logic will be similar for all languages. Okay. Yeah. Thank you, guys. Have a good day.